Right. Hello, everyone. I think it's time to start. And my name is Aydar Mukhametzyanov, and I'm going to talk about how we make Kotlin and Swift friends. And I will talk about new technologies in tooling mostly. I mean, only in tooling for Kotlin Multiplatform Mobile. But I will not talk about memory model, concurrency, coroutines in Kotlin native, etc. A little bit about me. I used to be an iOS developer from 2012 until I joined JetBrains in 2019. And currently I work in AppCode team. Who doesn't know AppCode? It's JetBrains IntelliJ IDE for developing iOS and macOS applications. By the way, I have a question. Do we have iOS developers in the audience? Oh, that's cool. Okay. All right. Yeah, I guess all of you know what Kotlin Multiplatform Mobile is, but good to repeat that Kotlin Multiplatform is a technology which allows you to share the same code for different platforms, and if we remove JS part, it becomes Kotlin Multiplatform Mobile. And for KMM already exists some tooling, for example, KMM plugin for Android Studio. I guess everybody knows that as well. And it's useful. It brings some useful functionality. For example, the project wizards, where you can create very basic KMM application. Also, you can run, debug, and test Android applications, and of course, iOS applications. And yes, but this solution has some problems for iOS development. And the first one, which I would like to highlight, is that Android Studio doesn't have any language support for Swift. So if Kotlin code looks very highlighted and completion works there and everything's super cool, but Swift looks like you would code in just text editor with basic highlighting of keywords. Another problem is related with a very late stage of integrating binary framework into iOS application, into iOS project. And to make your shared framework, binary framework, available from your Swift or Objective-C code, first you need to build it. And if you want to add new function or rename something, then you add new code. Again, you have to build it to make it available in your iOS project, and you end up in this circle of development, and it's not very fast. And another problem is related with the huge gap between Kotlin and Swift. Of course, these languages are similar, but they actually are very different, and they live in very different universes. And for example, if you have a declaration in Kotlin, or if you have a declaration of some class, and you use this class in Swift file, then first of all, this declaration will be highlighted as unused because Kotlin code doesn't know that somebody in Swift uses it. And if you try to navigate to this Kotlin code, like if you try to navigate from Swift file to your declaration in Kotlin, you will not be navigated to Kotlin file. For example, that's how this generated Objective-C header looks like for generated Kotlin framework, I mean binary from Kotlin framework. And to solve your problem of finding a declaration, you need to use just text search in your project. A short overview. First of all, it's lack of Swift support and necessity to rebuild every time you add new API to your Kotlin framework, and very complicated relationships between Kotlin and Swift because they're very different. And that would be nice to make these two languages kind of friends. And when I say Swift, I mean iOS. So let's take just Swift. It's kind of Objective-C and iOS. In AppCode team, yeah. Guess who then supports the Swift language? Exactly, AppCode. That's why we develop our tooling currently in AppCode, and that's where this KMM plugin for AppCode comes to the stage. What is it capable with? First of all, KMM plugin for AppCode allows you to develop KMM applications. So Kotlin is supported in the AppCode. Highlighting, auto-completion, everything works in Kotlin. Of course, you can run, debug iOS applications and Android applications. And the coolest feature of this plugin is that all the language support, like go-to declaration, renaming, and all the refactorings, they work with all these 3 languages, like with one language. If you rename it in one part, then it will be renamed everywhere at once. So let's do a short demo. I have a demo pre-recorded, and I hope the font will be big enough, and I hope I will be able to start it. All right. So let's say we have a Swift file, and there, you see, you can navigate, and you now navigated to the Kotlin file. Now, you see that it's in shared Kotlin framework. Now let's find all the usages of this greeting function, and it finds all the usages in Swift, also in Android part also it's found. Okay, it works. Now let's rename it. Yeah, let's rename it to hello string, for example. And it renames everywhere in Android part, and later we will see that it's done also in iOS part. Okay, navigation still works. Then let's add a new property. We add new property, and you will see how it immediately is highlighted as unused, of course. We go somewhere to the Swift file. Okay, here we see hello string. Let's see what happens if we try. Yes, and it's immediately available in auto-completion. You can navigate there, and it's navigated as a used property. So that was the demo. And you see that it all happens without any building. It's just on the fly, updates all the symbols. Before we go deep into this magic happening between Kotlin and Swift, I need to say a couple of words about some theory. So what is a symbol? Symbol is some structure of which contains it's a representation of how IDE sees your declarations. So IDE creates a symbol object, and symbol object contains all the information. For example, location in the file. It contains name. It contains some attributes. For class, it could contain relationships with another classes, like okay, I'm child of this class. I implement this protocol, etc. So basically, it's information about this like piece of declaration. And all the symbols, they are stored in symbol tables. So these symbol tables they allows us to find quickly the symbols just from the code. And for this small example of Swift code, a symbol table would look like this. So we just take all the declarations. We take class, we take properties and functions without function body. And if you want to know more about building the symbol tables and how we invalidate them, how we manage them, you can watch the talk about how AppCode works under the hood. It was in 2020 at NS Spain. All right. Regarding this cross-resolve between languages. So this, to work with 2 different languages as with one language, we need to convert the symbols of different languages, like symbol of one language to symbols of another language. For Objective-C and Swift, it's quite easy because in Swift compiler or it's in SourceKit, we have some naming rules, and that's how we could take Objective-C symbol, create a Swift symbol from this symbol, and vice versa. And we also have a cross-resolve between Kotlin and Swift, but it works a bit differently. How does it work? Let's say we have a property, hello string in Kotlin, and we would like to somehow translate it into hello string property in Swift. Let's have a look at how it works if you use just Xcode, for example. So you have this Kotlin declaration, and between your Kotlin declaration and Swift declaration, you have really dark forest. You can just create it. So you go to Kotlin compiler and ask this compiler to build the project. It builds the project and generates the framework, which includes also Objective-C header. In this Objective-C header, we could see, there is a property hello string. We create a symbol for Objective-C, and from this Objective-C symbol, we create a Swift symbol. All right, pretty long way, not straightforward. Let's have a closer look to what happens inside Kotlin compiler. Kotlin compiler takes Kotlin code, it gives it to Kotlin frontend. Kotlin frontend creates intermediate representation. This IR also, Kotlin compiler gives it to appropriate Kotlin backend. In our case, it's Kotlin native backend. And Kotlin native backend already generates binary framework. Let's have a closer look to Kotlin native backend. Before, it would take this IR and it would generate directly, for example, for Objective-C header, it would generate directly text, just like, okay, we import this, and we have this class and this class with these properties. And we introduced some intermediate Objective-C symbol structure from which it's possible to create Objective-C symbols. So we just added one more layer of representation, and we use this layer, like these structures, for both, for generating final framework and for generating our Objective-C symbols. And from these Objective-C symbols, we are able to generate Swift symbols. And what is happening above the line, it's in Kotlin compiler, and below the line, it's AppCode and KMM plugin for AppCode. And now, this way of getting Swift symbol from Kotlin symbol would look like this. We first get internal compiler structures. From this, we get Objective-C symbol, and from that, we get Swift symbol. And this part with internal compiler structure is quite new. I mean, yes, it's new. That's the innovation brought by KMM plugin for AppCode. What advantages we get with this new approach? First of all, it updates on the fly. So whenever you code, change your Kotlin code, we observe this file. We analyze if we need to update our symbol tables, and if we need, then we just rebuild incrementally our symbol tables. And these symbols are immediately available without any build. It's immediately available in Swift code and Objective-C. Also, because symbols contain all the information about declarations, we know where we need to go to find this declaration, also in Kotlin file. So that allows us to support proper language support, proper language features. Like go-to declaration, refactoring. So basically, what I showed in the demo, that's how it renames everything at once. And the last but not least, actually I like it the most, that if with the old way to get your Kotlin framework, to build your Kotlin shared Kotlin framework into binary framework, you would need first to have valid Kotlin code, right? And if you have some syntax mistakes there, it wouldn't work, and you couldn't code anything in Swift. But with this approach, here, actually Kotlin compiler, it works in another mode, so it would recover after some syntax mistakes. It would recover and continue working and continue parsing whatever it can parse and provide symbols it can provide. And that's very cool, so you could fix your mistakes a little bit later. All right, that's wonderful. Now we don't need to rebuild every time we change our Kotlin framework. Okay, then we type something we use some symbols from Kotlin framework, and we see that in Swift, we will get this annotation, like this red annotation that, oops, actually this class doesn't have this property. And the problem is that SourceKit gives this annotation to you because, because I will explain it later. What is SourceKit? Who knows what is SourceKit? iOS developers, not less than less than in previous question. So SourceKit is a language server for Swift. It's like a brain of Xcode for working with Swift language. And Xcode uses it for everything, for navigation, for highlighting, for auto-completion, and for many, many more. And AppCode also uses it. For example, it uses it for completion in dump mode during the indexing. Navigation works during the indexing through the SourceKit, and it takes all the annotations from SourceKit. And that's where this red underline comes from. Let's have a look at this problem, why it happens. So we have my framework written on Kotlin. We have some Swift file. And in my framework, and of course SourceKit, and in my framework, we have this hello string property. And first, we import this from my framework in Swift file. And SourceKit says, oops, I don't know this framework. That happens because IDE knows about this framework. It has all the symbols. It knows, OK, there is this framework. There are some symbols in there. But SourceKit doesn't care about Kotlin files. It cares only about files it can understand. And it can understand only, in our case, only Objective-C framework, which will be generated if we build the project. So to make SourceKit happy, we need to build this project, get this generated Objective-C framework, and then SourceKit is happy. All right, we made it happy. Now we use this hello string, and then let's perform rename. We rename it, and SourceKit again is not happy because we renamed it only in Kotlin file, in Swift file, but we forgot to rename it in our generated framework, which we passed to SourceKit to get some annotations. And SourceKit, again, is very confused and not happy. And this is a big problem. We can't live with that because it makes us, again, it makes it necessary to rebuild the framework every time we change Kotlin code. But let's have a closer look at what is the binary framework. It contains a header file. It contains module map for Swift and some info plist and very heavy and very fat binary, which contains all the implementation. So it's like the binary, you know. And this is very heavy, and it's very. It takes quite a lot of resources to generate this binary file every time. That's why build takes so long. But SourceKit doesn't care about this binary. SourceKit needs only header and module map, and header will contain all the symbols which is necessary for SourceKit. And we do generate only this part. So every time you do some changes in Kotlin framework, and we decide that it's necessary, we generate some kind of framework stub. We call it stub because it's not really framework, it's just some trick for SourceKit to make it think that, okay, there are some symbols there. And yeah, you even can find it in the build folder if you try out the KMM plugin currently. And naive approach would be to generate this framework stub every time you update your Kotlin code, but there are some optimizations for that. First of all, we don't need to generate it right after you change your Kotlin file. Actually, we need to generate it only right before you open the Swift file, or right after you open and when all the annotations are requested from SourceKit. So first we need to regenerate it quickly and then request annotations. And the second optimization is related to the fact that we don't care about implementations of functions or comments. We need only API. And it's like in this example, we care only about declaration, but not the body and comments. And that works quite well and makes us happy and still solves the problem. The last section of my talk, quite fast talk, I would say, is a project model. The project model is a structure of your project, and that's how IDE could understand where source files lays, where test source files lays, where it could find something, where it could find some source files for particular target. And usually Kotlin projects configured through Gradle, I mean in Kotlin Multiplatform. And all the iOS things, it's configured with an Xcode project file. And somehow, we need to make them work together. If you go to JetBrains.com and download AppCode and install KMM plugin for AppCode, you will see that we resolve this problem by configuring iOS app in Gradle as well. So we configure Kotlin shared, we configure Android app in Gradle, we configure iOS app in Gradle. And it's possible with the Gradle extension we wrote as well. It's Apple Gradle plugin. And there you can configure your iOS target. So it's like these properties are very similar to what you see in your Xcode project build settings. You can configure also dependencies and many, many more. And we just take this information and create the project model. And when you build the project, AppCode actually generates Xcode project for you. And also, this Xcode project is generated if you want to open a storyboard, for example. So if you open the storyboard, then it generates the project, it opens the storyboard, you set up all the outlets from there, and then you continue in AppCode, and you're happy. So as you see, this exactly this part is source of truth for iOS in this approach. But also, probably not everybody would like to get Xcode project generated from Gradle file. So that would be nice to actually keep your Xcode project and make them still work together. And yeah, we call it hybrid approach, where you configure Kotlin shared and Android application in Gradle. You still have iOS application configured in a traditional Xcode project or in Xcode workspace. But the only current requirement, probably it could be changed because it's still under development, that it has to, the Kotlin framework should be integrated with Kotlin or with Kakao pods. So I guess you know this piece of code as well. In Kotlin shared framework, you can configure a Kakao pod, like export as a Kakao pods. Wonderful. Yeah, as I said, it's under development. It's not available yet. It's not public. I hope we will be able to show it at some point in future. Yeah, I hope in next year. Going to conclusions. First of all, you saw that cross-resolve between Kotlin and Swift already exists, and you already can try it out. You already can create some projects there. And in future, Kotlin Multiplatform Mobile will be more and more friendly to our iOS developers. So if you have some fears or you think that it will be hard to convince iOS developers to move into Kotlin Multiplatform, so it will become a bit easier, I hope. And developing all this stuff is very hard. But it's very interesting. Thank you very much. That was all.